Good morning, everyone. I'm Ebaneshar Vedharaj. I'm excited to present our project Vehicle CO2 emission essential using machine learning. In an era where climate change is the most pressing global concerns, reducing carbon emissions has become a priority. The transport sector, particularly motor vehicles, is a significant contributor of CO2 emission. Accurating essential of emissions is crucial not only assessing environment impact but also supporting a development of cleaner vehicle technology and regularly policies. Our approach to solve this problem leverage machine learning to create a predicting model that essential vehicle CO2 emission based on various features. In scenes relying on traditional often time consuming laboratory tests, we use data driven method to build a more scalable and efficient solution. The data set we use to consider several vehicle attributes including engine size, fuel type, fuel consumption, vehicle class, and transmission time. By analyzing these features, we aim to develop a robust and reliable model that could provide accurate emission features. To achieve this, we implement the multiple linear regression based machine learning algorithm. We start to simple linear regression. It's model that relationship between single and independent variable and CO2 emission while comparatively effectively. This approach was quite limited and incorporate the complexity of emissions, as it only considered one factor at a time. The model performance was measured using key evaluation metrics such as mean absolute error, mean square error, and R square error. Our findings shows that simple linear regression R2 value is 0.75, meaning it could be example 70% of various emissions, which is insufficient of real world applications. To improve accuracy, we expanded our approach using multilinear regression. This is allowed to us incorporate multiple predictor variable, significantly engage the model able to capture emission variability. With the approach, we achieve R square value 0.87, improving prediction accuracy. However, we encounter issues of multicollinearity, where some independent variables were highly correlated with each other, casting insufficient in the model coefficient. Recognizing the non-linear nature of vehicle emission, we also implement the k nearest neighbor algorithm and support vector regression algorithm. KNN, a non-parameter method, providing better and prediction by averaging the emission of similar vehicle. However, it required significant computation power as the dataset size increased. Support vector regression, on the other hand, proved to be a most efficient model in our study. We utilized the kernel function SVR was able to capture complex and non-linear relationship between the input feature and the CO2 emission, achieving the highest R square value of 0.91, the lowest prediction error. Our model evaluation showed that while simple linear regression like and linear regression has provided a basic understanding, advantage of technical like SVR and KNN offer significant improvement of accuracy. The ability to integrate machine learning into emission establish open new possibilities for the automobile industry and the environment policymaker. Manufacturer can be used with this predictive model to design lower emission vehicle, while government can leverage this data to formulate more effective regulation for suitable transportation. Despite our success, we faced several challenges throughout the project. One of the key issues was handling a missing and inconsistent data. What we addressed by applying imputation techniques and future scaling. Additionally, the high dimensional nature of the dataset required users carefully selected and engineered features to avoid overfitting while maintaining the model independently. Hyperparameter tuning played a crucial role of optimizing SVR and KNN better performance. Looking ahead, we see several opportunities for improvement. Integrate deep learning techniques could engage predictive accuracy where future by capturing integrate patterns in the data. Additionally, expanding our data set to include real-time emissions from various dividing conditions would provide a more comprehensive understanding of CO2 emissions. Future work could also explore cosmetic analysis incorporate traffic pattern and environment factor to refine our predictions futures. In conclusion, this project highlights the potential of machine learning in addressing real-world environment challenges by leveraging data-driven approach. We can move toward more sustainable vehicle technology and informed policy. Our work demonstrate that predicting model is not just about improving accuracy, it's about making meaningful contribution of greener futures. Thank you for your time. Now we discuss about predicting vehicle CO2 emission notebook file. Firstly, importing the natural libraries of Pythons, NumPy, Pandas, Metasploit, and Cpon and Plotly. Moreover, first we include our dataset file CO2.csv file. We save as our dataset file as CSV files. Next we copy the dataset file as TF files. The 5 samples of dataset files is this. And the info file is we using the level columns that is include as this used as the independent variables of using predicting the model. Next we described our model, the unique an element of model, the number of vehicle class we uniquely used in the model. Next we convenience to renaming the features name as like this, smaller letter and easy to understand and ourselves. This info of dataset is make is 7385 columns and non-null object. There are some of the integers values are included. We convert this our convenience to easy to predict our model. Next the brand of unique used is the brand dot unique is used to how many unique brand values are used in our model. The brand values indexes are alpha review. There are like so much. There are models are used in our model. Car models are the external capture values, the unused values are set as is using to predict. Engine size. There are these are the features values we are preparing this feature values to convenience to model to predict. Also finally These all codings are preparing the data sets to train the model. First we clear the data set to easy to predict our model. First we use the simple linear regression model. We import the simple linear models and train test split functions and also the evaluation functions mean square error, R square errors and mean absolute error. We are used as depending value was engine size and the independent values used as CO2 emission. We split our data set as 0.2. This are 80% of data is used as train and 20% data used as test size. The linear regression import and we fit our model using to predict and evaluate our model. This is our evaluation score of our simple linear regression used to predict our data set. Next we use the multilinear regression. The multilinear regression uses the sum of the features values or engine size and fuel consumption per liter per 100 km. Fuel consumption by highway the liter per 100 km. Fuel consumption city liter per 100 km. We use the independent values as CO2 emission gram per kilometer. We split the data set also. Also the previous data set we used to split like this. And we fit our train and test data sets. And we predict that test values to evaluate our model. We using the evaluated mean square of error and mean absolute error and R square value. These are the three metrics of used to evaluate our multilinear regression model. This our graph shows how our model is evaluation results. This is not bad. Next we move on to the KNN model. KNN model, we import our KNN model using KNN.nearest library from the k-nearest classifier. We use some of the columns to the like previously multilinear regression use the same feature used as KNN model and also a CO2 emission predictor model. Like the previous we use the same the method of following is we split our data set as 80 and 20%. like that we train our model. We used a three value given us three near neighbor values are used as predict our test values. Like as we predict and evaluate our model, and next we move to rigid regress model. Rigid regress algorithm we used to predict our model. They are used as some of the column to predict our model. Like as train and test split and 80 principal percentage. Train our model, the evaluation. Last we used a support vector regress model. This model is high value performed. We like split and data set, train and test data set and train our model, evaluate our model. Finally, we compare the all of the regression model to which are the best. There are simple images, so it's the highest error values, and the KNN shows the lessest values of mean absolute error. The best model is support vector model. This is shows the highest result, and also a KNN is also a same level result of our model. Thank you. This also.